All right, we're going to continue on with our geometric sequences. We're going to start with number 11. For 11, 12, and 13, it says write the geometric sequence, the first four terms, using the general equation. Do you notice anything? Well, if I were to write the first term, that would mean my first term was n equals 1. So I'm going to plug n equals 1 into this formula. So my first term is 2 times 7 to the 1 minus 1 power, which is 2 times 7. 1 minus 1 is 0. And I know that anything to the 0 power is 1. So that becomes 2 times 1, which is just 2. Do I notice anything? The first term is 2, which is the same thing as the first term in my formula. That's pretty nice. So if you're just trying to find the first term, you really don't even need to use the formula. You can just, you take a look at the formula and go, that first number is 2, that's my first term. So I start with 2, and then I know that that is my ratio, so each number is being multiplied by 7. So I can just take a calculator and go, well, it's 2 times 7, 14. All right, what's 14 times 7? It is 98. And what's 98 times 7? 686. And I only have to find the first four, so I stop there. You go ahead, pause the video, and do number 12 and 13, and then see if you're right. All right, let's go on to number 14. This says write the general formula equation from this geometric sequence, kind of like what we were doing before. What I want to do is I want to identify my first term, and I want to identify my ratio. 4 to 36 is being multiplied by 9. And I'm just going to quick double check to see if 36 times 9 does indeed equal 324, and it does. Great. Now I just have to plug that into my formula. A to the n is my first term times my ratio to the n minus 1 power. And there we go. Go ahead and pause this and go ahead and do numbers 14 through 17, and you can also see if you can do number 18. So hopefully we've done pretty well with these problems, especially on one like this. You just have to do an extra step of finding what the general equation is. Then you can use your general equation to find the 11th term. Technically, you could have multiplied each of these terms by 3 to, get up to the 11th term. You just could have cranked out the numbers that way. That would have worked too. All right, now we're going to get into some slightly more challenging problems. These ones you might want to write a little bit small because we are probably going to fill up this entire section. All right. This says, find the general equation and the first 5 terms of the geometric sequence whose 7th term is negative 320 and the 11th term is negative 5,120. Hold on. We don't even know what the first term is, and we don't know what the ratio is. So if we don't know what the first term is and the ratio is, how can we find the general equation? Well, when in doubt, let's write out what we know. I know that the 7th term is negative 320, and I know that the 11th term is negative 5,120. I do not know what my first term is, and I don't know what my ratio is. I need to know what both of these are in order to get my general equation. Well, I could go ahead and write an equation using these. So my general equation, a to the n, any nth term, is my first term times my ratio to the n minus 1. So I'm going to write a equation using at least what I know of this. Let's see, my 7th term is negative 320. Okay. And that's going to equal a times r, and this is the 7th term, so 7 minus 1 is 6. Okay. I'm going to do the exact same thing for this one, for my 11th term. I know my 11th term is negative 5,120, and that's going to equal my first term times my ratio to the n minus 1. N is 11, so 11 minus 1 is 10. Okay, I have these two equations. What could I do with them? Here's something that's kind of funky. I could actually kind of do a funky system of equations. Before, we would do system of equations and we would add or subtract these equations to get a new equation. I'm going to actually divide these equations. So I'm going to rewrite these equations up here. I'm just going to rewrite this one on top because it has a higher exponent. So I'm going to rewrite here, and you're going to see something pretty cool happen. Okay, so I just rewrote these two equations here, and I just flip-flopped them. I'm going to actually take this equation, and I'm going to divide it by this equation. And I can do that because I know that this amount is the same as this amount. This amount is equal to this amount. So if I divide by an equal amount, I've kept my equation balanced. I can divide both sides of my equation by an equal amount and not change it. So I'm going to do negative 5,120 divided by negative, well, there's going to be positive, so I'll just do positive. 120 divided by 320. Ooh, 16. And I'm going to do a times r to the 10th divided by a times r to the 6th. Ooh, a divided by a. 1. I like that. R to the 10th divided by r to the 6th is r to the 4th. I'm just using my exponent rules. 10 minus 6 is 4. And then I get this fabulous r to the 4th equals 16. I only have one variable. I can solve for this. What number to the 4th power equals 16? 2. 2 to the 4th power is 16. I have got my ratio. That is awesome. So now I have my ratio, and I can use my ratio to work backwards and figure out my first term. I have two equations here. I have this one and this one. I'm just going to pick one of them to figure out and plug r into. And I'm going to go ahead and do my smaller amount because I like smaller numbers. So I'm going to do negative 320 equals a times r to the 6th. I know that my ratio is 2, so I'm going to plug that in there. 2 to the 6th, and I'm just going to simplify. 2 to the 6th power, what is 2 to the 6th power? 2 to the 6th power is 64. So I have negative 320 equals a times 64. I'm going to go up here. Woo! I'm going to divide both sides by 64. So negative 320 divided by 64, negative 5. So a equals negative 5. Awesome. Okay. Oh, but have I figured out the answer yet? No, I need to find the general equation. I can do that now because I know that a equals negative 5, and I know that my ratio is 2. And then I can just find my first 5 numbers. So my general equation is a to the n is my first term, negative 5 times my ratio, which is 2 to the n minus 1. Here's my general equation. And then my first 5 numbers, I could squeeze them in under here. My first one is negative 5. Each one is being multiplied by 2, so I'm just going to multiply by 2. Negative 5 times 2 is negative 10. Times negative 2 is negative 20, times negative 2 is negative 40, times negative 2 is negative 80, and they would continue on, so on and so forth. There we go. So this is a really cool system where you can actually, even if you don't have, if you have 2 of the numbers, you don't have the ratio or your first term, you can figure them out using kind of a funky form of system of equations. Instead of adding or subtracting the equations, you come up with your kind of general equation, and then you actually divide your equations. And then from that, you're going to get what your ratio is, and then you can plug your ratio back in into pick one of the equations, doesn't matter. You're going to figure out what your first term is, then you can create your equation. Whew! It's a lot of steps, but it's not too bad. you go ahead, pause the video, and work on numbers 19, 20, and 21, and then check on back in and see if you get the right answer. Alrighty, that was a whole lot of work. Hopefully that after those 3 problems, you were beginning to catch on and get kind of the rhythm of that. Take a moment and review. What do you need to remember about geometric sequences? Write yourself a note below. And just keep in mind that problems like 19, 20, and 21 are definitely high-level complex problems. You will not get any of those on your MCAs, anything like that. But you will see them again in your A-apps.